Welcome to Intelligence Gateway.
Module 1, Introduction to Databases. Overview of databases and database management systems. Databases and database management systems, DBMS, play a crucial role in managing and organizing data in modern computing systems. Here's an overview of databases and DBMS. What is a database? A database is a collection of structured data that is organized, stored, and managed in a way that allows for efficient storage, retrieval, modification, and deletion of data. Databases can be of various types, such as relational, object-oriented, hierarchical, network, and more. What is a database management system, DBMS? A DBMS is a software application that enables users to interact with a database and provides an interface for managing and accessing the data stored in the database. It acts as an intermediary between the users and the database, allowing users to interact with the database without having to directly manipulate the underlying data. Key features of DBMS. 1. Data Definition Language, DDL, allows users to define and manage the structure of the database, including creating, modifying, and deleting tables, views, indexes, and other database objects. 2. Data Manipulation Language, DML, allows users to interact with the data stored in the database, including inserting, updating, retrieving, and deleting data. 3. Data Query Language, DQL, allows users to retrieve data from the database using query operations, such as select, to filter, sort, and aggregate data. 4. Data Integrity, ensures that the data stored in the database is accurate, consistent, and follows predefined rules and constraints. 5. Concurrency Control, manages concurrent access to the database by multiple users or applications to prevent conflicts and ensure data consistency. 6. Security and Access Control, provides mechanisms to secure the database and control access to data based on user roles, privileges, and permissions. 7. Backup and Recovery, provides features for creating database backups and recovering from data loss or system failures. 8. Scalability and Performance, optimizes database performance and scalability to handle large amounts of data and concurrent users. 9. Data Modeling, allows users to define the structure and relationships between data elements in the database using data models, such as the relational model or object-oriented model. Popular DBMS. 1. Relational DBMS, examples include Oracle Database, MySQL, Microsoft SQL Server, IBM DB2, and PostgreSQL. 2. NoSQL DBMS, examples include MongoDB, Cassandra, Redis, and Amazon DynamoDB. 3. NewSQL DBMS, examples include Google Spanner, CockroachDB, and TDB. 4. Object-oriented DBMS, examples include MongoDB, OrientDB, and ObjectDB. In conclusion, databases and DBMS are essential components of modern computing systems, providing efficient and organized storage and management of data. They enable users to interact with data in a structured and controlled manner, and provide features such as data integrity, concurrency control, security, and performance optimization to ensure reliable and efficient data management. Comparison of different database management systems. There are various types of database management systems, DBMS, available, each with its own strengths and weaknesses. Here's a comparison of some popular types of DBMS. 1. Relational DBMS. Relational DBMS use a relational model to store data in tables with rows and columns, and support SQL, structured query language, for data manipulation. Examples include Oracle Database, MySQL, Microsoft SQL Server, IBM DB2, and PostgreSQL. Suitable for structured data with complex relationships. Offers ACID, atomicity, consistency, isolation, durability, properties for data integrity and transactions. Provides robust support for data modeling, relationships, and normalization. Suitable for complex business applications, data warehousing, and large-scale data management. May require predefined schema and fixed data structure. 2. NoSQL DBMS. NoSQL, not only SQL, DBMS do not use a fixed schema and provide more flexibility for storing unstructured, semi-structured, and distributed data. Examples include MongoDB, Cassandra, Redis, and Amazon DynamoDB. Suitable for handling large volumes of unstructured or semi-structured data, such as social media data, sensor data, and multimedia data. Provides high scalability and performance for distributed and parallel processing. Offers flexibility in data modeling and does not require a predefined schema. Supports horizontal scaling and can handle big data and high-velocity data. May not provide ACID properties and may have limited support for complex queries. 3. NewSQL DBMS. NewSQL DBMS are relational databases that are designed to offer improved scalability, performance, and concurrency compared to traditional relational DBMS. Examples include Google Spanner, CockroachDB, and TDB. Provides the benefits of traditional relational DBMS, such as data integrity, transactions, and data modeling. Offers improved scalability and performance for distributed and parallel processing. Provides horizontal scaling and high availability. Suitable for modern applications with high scalability and performance requirements. May have a steeper learning curve and higher cost compared to traditional relational DBMS. 4. Object-oriented DBMS. Object-oriented DBMS store data in object-oriented models, where data is organized as objects with properties and methods. Examples include MongoDB, OrientDB, and ObjectDB. Suitable for storing complex objects and hierarchical data. Offers flexibility in data modeling and supports complex relationships. Provides support for encapsulation, inheritance, and polymorphism. Suitable for applications that require handling of complex data types, such as multimedia, spatial, or temporal data. May have limited support for complex queries and may not offer full ACID properties. In conclusion, the choice of DBMS depends on the specific requirements of the application, such as the type of data being stored, the scalability and performance requirements, the need for data modeling and relationships, and the level of data integrity and transaction support needed. Each type of DBMS has its own strengths and weaknesses, and careful consideration should be given to the specific needs of the application before choosing a suitable DBMS.